Hey all, today we are talking about GenAI. We want to dive into the differences between GenAI and machine learning. So, two very common questions asked are what is artificial intelligence and what is the difference between AI and machine learning? Also, a few days ago, I passed a very nice GenAI course on LinkedIn. I will share the link in the description and would like to share some fresh knowledge with you. So be ready to take notes, grab your favorite drink, and we are starting. Imagine having a super smart robot friend. This friend doesn't just follow commands, but think, learn, and make the decision on his own. That's what AI is. A brilliant branch of computer science, all about creating machines that can think and act like us, like humans. AI is like a big, adventurous discipline like physics, biology, etc. And now, inside this world of AI, there is an exciting area called machine learning. This is where computers learn from data without us telling them exactly how to do everything. They're like curious students gathering knowledge from their experiences. They are like we are right now. Uh, we are gathering knowledge and we are starting and becoming the better version of ourselves. In this discipline, we have machine learning, which is a subfield of AI. This is a program or system that trains a model from input data. The trained model can make useful predictions from new or never before seen data. Data drawn from the same one used to train the model. Machine learning gives the computer the ability to learn without explicit programming. So we can see here that artificial intelligence is a discipline and machine learning is subfield. And from the machine learning perspective, we can talk about two predominant types: supervised and unsupervised models. Supervised models distinguish themselves by utilizing labeled data. This is kind of data is like annotated with specific markers such as names, categories, or numerical values. On the other hand, we have unsupervised model which work with unlabeled data which lacks those explicit markers. Consider the scenario of restaurant owner analyzing historical data on bill amounts and corresponding tips, categorized by the nature of the order and its delivery method. In this instance, a supervised learning model would employ this historical data to forecast future tipping behaviors based on the total bill amount and whether the order was for pickup or for deliver. Conversely, an unsupervised learning model might tackle a different challenge. For example, it could analyze employee tenure and income data to categorize employees into different groups, aiding and identifying those on a rapid career advancement path. Unsupervised learning excels in uncovering hidden patterns within raw data, grouping them into meaningful categories. To delve further into those categories, those concepts, let's visualize how supervised learning operates. In this approach, the model receives the data values x, here we go, and generates predictions. Those predictions are then evaluated against the actual values from the training data. A significant deviation between predicted and actual values indicates an error, which the model aims to minimize. thereby aligning predictions more closely with reality. This process represents a classic optimization challenge. Having discussed the nuances between AI, machine learning, and the distinct approaches of supervised and unsupervised, learning is also valuable to touch upon the role of deep learning. Deep learning is a subset of machine learning techniques, utilize more intricate structures known as artificial neural network to process and interpret complex patterns in data. While machine learning is a broad field that encompasses many different techniques, deep learning is a type of machine learning that uses artificial neural networks, allowing them to process more complex patterns than machine learning. Artificial neural networks are inspired by the human brain. They are made up of many interconnected nodes or neurons that can learn to perform tasks by processing data and making predictions. Deep learning models typically have many layers of neurons, which allows them to learn more complex patterns than traditional machine learning models. And neural networks can use both labels and unlabeled data. This is called semi-supervised learning. In semi-supervised learning, a neural network is trained on a small amount of labeled data and a large amount of unlabeled data. The labeled data helps the neural network to learn the basic concepts of the task, while the unlabeled data helps the neural network to generalize to new examples. Now we finally get to where generative AI fits into this AI discipline. GENAI is a subset of deep learning, which means it uses artificial neural networks can process both labeled and unlabeled data using supervised, unsupervised, and semi-supervised methods. In the big universe of machine learning, there is a super cool area. Yeah, deep learning is super cool area. And large language models, like the ones that can write stories or answer questions, are part of this deep learning family. Let's talk about two types of learning model. Yeah. In deep learning, we have two main types of model: generative and discriminative. Think of discriminative models as smart detectives. They look at data like pictures or text that we are already tagged and learn to identify and categorize new similar data. It's like showing them a bunch of cat and dog photos, and then they learn to tell which is which. Generative models, on the other hand, are the artists of the AI world. They don't just categorize, they create new stuff. For example, if you show them a lot of dogs' pictures, they can learn to draw a brand new picture of dog. Those models look at all the data they are seeing and imagine something new and unique. Generative AI is super exciting because it's all about creating. It can write text, make images, even generate video, and even based on your voice, create your video with your voice on different languages. Think about it. It learns from a lot of information, like text or pictures or audio, video, etc. It can use that knowledge to come up with new creative things. Let's think about how we used to program computers in the old days. We had to give them every single rule, like telling them exactly what makes a cat, But now with AI, we show them lots of cat and dog pictures and they learn to recognize them on their own. And with generative AI, they can even create their own cat pictures or stories about cats. Let's talk about transformers. Uh, a big a big stuff in AI came with something called transformers around 2018. This is like complex systems in AI models that help understand and generate language. But sometimes it can get a bit confused and create funny or incorrect sentences. That's why AI developers work hard to train those models even better with lots of data and give them the right context. What's the coolest part from all of it? You can interact with those AI models and ask them to create things for you. It's like having a super smart helper or assistant who can write, draw, and even make videos based on your ideas. Whether you're curious about the meaning of life or want to see a new kind of animal, AI can help you explore those ideas in a fun and creative way. So it's like a quick tour of amazing world of deep learning and generative AI. It's like stepping in the future where computers are not just tools but also creators and helpers in our journey of imagination and learning. So we need to stay curious and try all those new stuff because they are obviously helping us in our daily life, in our private or professional life. Let's talk right now about different generative AI types. First type is text to text. Text to text models can take a natural language input and produces a text output. Those models are trained to learn the mapping between a pair of text, for example, translation from one language to another. Next one, text to image. Text to image models are trained on a large set of images, each captioned with a short text description. Diffusion is one method used to achieve this. Next one, text to video and text to 3D. Text to video models aims to generate a video representation from text input. The input text can be anything from a single sentence to a full script, and the output is a video that corresponds to the input text. Similarly, text to 3D models generates three-dimensional objects that correspond to a user text description. For example, it can be used in game or other 3D world. Next one, text to task. Text to task models are trained to perform a defined ask or action based on text input. This task can be a wide range of actions such as answering a question, performing a search, making a prediction, or taking some sort of action. For example, a text to task model could be trained to navigate web UI or make changes to a doc through the GUI. A foundation model is a large array model pre-trained on a vast quantity of data designed to be adapted or fine-tuned to a wide range of downstream tasks such as sentiment analysis, image captioning, and object recognition. It's foundation model. We don't have this type of model on our screen, but I would mention this model. They also can be used to detect fraud and provide personalized customer support. Also, we have another type, it's Vertex AI, offers a model garden that includes foundation models. The language foundation models include Palm, API, for chat and text. The vision foundation models include Stable Diffusion, which has been shown to be effective and generate a high quality image from text descriptions. Let's say you have a use case where you need to gather sentiments about how your customers are feeling about your product or service. You can use the classification task sentiment analysis task model for just that purpose. And what if you needed to perform occupancy analytics? There is a task model for your use case, yeah. Um, let's look at the example of code generation show here. Yeah, we are using Google Bard for it. It's in this example we input a code file conversion problem converting from Python to JSON. And for this one, yeah, we are using Google Bard. We insert into the prompt box the following. Here we have a pandas data frame with two columns, one with the file name and one with the hour in which it's generated. We're trying to convert this into a JSON file in this format shown here on screen. Bard returns the steps we need to do this and the code snipped. And here output is in JSON format. It's get better, yeah. It happened to be using Google's for free browser-based Jupyter notebook known as Colab. I simply export the Python code to Google Colab. Yeah, let's break down some awesome tools in the world of coding AI, what make life easier, at least for developers, but I think they have very easy life. Ha ha ha. Okay, about Bard code generation. It's coding assistant. Think of Bard code generation like a super smart coding body, yeah? It can check your code for mistake debugging, explain your code to you piece by piece, and even write complex SQL queries for your database. It's also great at translating code from one programming language to another, and can automatically create helpful guides and tutorials about your code. We don't have here generative AI. We have generative AI studio, yeah, the ultimately AI playground. It's like a magical workshop for AI models on the Google Cloud platform. It's packed with tools and resources, making it super easy for anyone to start playing with generative AI models. You can find a bunch of ready-to-use models, tweak them to fit your needs, and even get them ready for real-world use. Deploy them. Plus, there is community forum where developers can exchange ideas and tips. So, in a nutshell, those tools are like having a high-tech AI lab at your fingertips. Whether you're building apps, playing with AI models, or making your code smarter, those tools are designed to make your tech journey exciting and productive. I hope this video was useful. So like this video, make comment, subscribe this channel, and thank you for staying with me. Have a nice day.